On the maze for elimination. So number 1, and this one they made it pretty simple actually, because this one's ready to do the elimination actually. X plus y equals -8. Okay, so this one, nice and simple. So the y's are ready to eliminate. If you were to combine them right now, they would cancel each other out. The other option you have is that you could change the signs of the top line to get the x's to cancel out, or you could change the signs of the bottom line, and that would also get the x's to cancel out. So would you like to leave the problem as it is and let the y's cancel out, or would you like to change a sign and get the x's to cancel out? What do you guys want to do? Say it again. Leave it how it is. Let's get the y's to cancel out. So if I leave this, the y's are going to go away. I'm going to combine these. I'm going to get 2x. And then when I combine these, what do I get? -14. So when I go to solve this equation, I have 2x equals -14. And then what do I do from there? Divide by 2. And I get x equals -7. Okay, so I solved for the first variable. Now I want to go back and solve for y. And how do I do that? Plug it in, and it doesn't matter which equation I do, so which one would you guys prefer? First or second? Doesn't matter. Which one? Second one. Okay, so we will do x plus y, so x plus y equals -8. And to get the y alone, we'll go ahead and add 7 to the other side. And so y equals -1. So do we just put a box around those and call it good? Box, box, that's our answer? No. What do we do? You write it as a point, because whenever you solve a system, the solution to the system is the point where the two lines cross. So we make sure that the final answer looks like a point. Okay. That is problem number 1, 2, 3. Okay, let's do three, 4. Okay, the next one I'm going to do is going to be what problem number 5 is. So this is number 5 when you go through the pattern. So this is x plus 2y. Equals 6, and 3x minus 4y equals 18. X plus 2y equals 6, 3x minus 4y equals 18. So on this one, we could cancel out the x's or cancel out the y's. It does not matter which one we do the elimination for. So when you're looking which variable to eliminate, you always want to become the bigger coefficient. So you would want both of these to be 4, you would want both of these to be 3, and then you want them to be opposite signs so that they'll cancel out. So would you rather turn this into a positive 4y so that it will cancel out, or would you like to turn this into a -3x so that it will cancel out? You want to get rid of the x's, or do you want to get rid of the y's? You want to get rid of the y's? So we're going to take the entire top line. We want to turn it into a positive 4y so that it will cancel out with a negative 4y. And if we're going to turn it into a positive 4y, what do we have to multiply the top line by? 2. So the entire top line is going to multiply by 2. So we're going to have 2x plus 4y equals 12. And then for the second line, we have 3x minus 4y equals 18. And if we combine those, the y's cancel. How many x's do we have? 5. 5x equals 30. And then what should we do from there? Divide by 5. Okay. X equals 6. Okay. So when you plug it back in to see what the other variable is, in this case to see what the y is, you can plug it into the equation that you change. So you could plug it into this one, or you could plug it into this one, or you could plug it into this one. It doesn't matter. I usually don't use the equation I changed because I made those numbers bigger, and so that's not as simple as one of the original equations. So I usually don't use that one. So which of these two would we like to use, first or second? First one. First one's got smaller numbers. So I'm going to use x plus 2y equals 6. And then I'll get my y alone. And divide by 2. And so what is my point of intersection? 6, 0. Okay. We're going to try problem number 8 now. Problem number 8 says 3x plus 7y equals 19. 2x plus 5y equals 14. How is this one different than the last one? Yeah, you've got to multiply both of them. So you can't just say 5 is going to become 7 if I multiply it by one number, unless I'm using fractions. In most cases, we probably don't want to use fractions. I can't just take a 2 and make it become a 3 unless I use fractions. So instead, when you do problems like this, you're going to think, what number could 7 and 5 both go into? And what number could 2 and 3 both go into? So if I was going to do 7 and 5, what number do you think of that they both go into? 35. If you think of 2 and 3, what number do you think of that they both go into? 6. So I'm thinking here, if I was to use this one, I would want to make the 5 into a 35, I would want to make the 7 into a 35, and I would want to make one of them negative. Doesn't matter which one, just one of them needs to become negative. Here, I would want to make them both into a 6, and I would want to make one of them negative. It doesn't matter which one. So would you guys rather go for the 35 and get rid of the y's, or would you rather go for the 6 and get rid of the x's? 6? Okay. So we're going to multiply the top by 2. We're going to multiply the bottom by 3. Which one do you want to make negative to get rid of, the top or the bottom? It doesn't matter. Top. Okay. So on the top, we're going to multiply by -2. On the bottom, we're going to multiply by +3. Doesn't matter if you did it the opposite, you're still going to get the same answer in the end. And if you worked with the y's, you're still going to get the same answer in the end. It really, truly does not matter. So I'll distribute my -2 all the way through the problem. So I've got -6x minus 14y equals negative, you're close, 38. Perfect. Okay. And then 6x plus 15y equals 42. Okay. So if we put those together, ooh, this is kind of nice actually. So the x's cancel. What happens with the y's? It's just one y, which is really nice. 8 is problem number 8.
Okay.
Yeah. Yeah. And then we have -38 and positive 42. 4. Y is 4. That's really nice. Okay. And then from there, what should we do? Plug it back in. So I'm not going to use these. The numbers got bigger. I'm going to go back to one of the original problems. Do you want to use the first one or the second one? Second one, the numbers are smaller, so it's easier. So we're going to do 2x plus 5 times the y value that we just got equals 14. So 2x plus 20 equals 14. I'll go ahead and minus the 20 over. 2x equals okay, and then x equals, okay, so the point is -3, 4. Marvelous. Okay. And that was our 8th problem. Okay. How are you guys feeling on those problems? Good? Got us unrusty? Do we need to see another one, or were those 3 good enough? Get us back in the swing of things. Those 3 were good? Yes? Okay. So just a reminder with the cell phones, once, All right, go ahead and turn to the very last page. For the most part, these are going to be elimination problems. Every so often you'll run into a substitution problem, but for the most part, elimination problems are more common for the way that they're written. So let's start off with the first one. So these are the word problems. I shouldn't hear any chatting in the back. All right. Says, at the movie theater, the Clayton family bought 4 fountain drinks and 3 bags of popcorn and paid $22.50. The Hanks family bought 5 fountain drinks and 2 bags of popcorn and paid $23.75. How much is a fountain drink? So with these, obviously we're not talking about 2 lines that are crossing. We're talking about answering an actual question, which means that you don't have to write your answer as a point. In fact, you should not write your answer as a point. That doesn't make sense. Your answer should be written as a sentence. And you don't necessarily have to solve for both variables. You only have to solve for one, technically. To be able to get the information you want, you might need to solve for both to get there, but you don't technically have to. So what I like to do is I don't typically use X and Y. I like to use the variables that make sense for the problem. So for this one, I would use D for fountain drinks, and I would use P for popcorn. And for me, anytime I'm having a hard time with figuring out what the equations are, sometimes the equations are really easy to write, sometimes they can be tricky. Anytime they're tricky, I like to write down what my variable actually means. So here, the D value is for, if you look down at the question, how much is a fountain drink? So D is the cost of a fountain drink. And P is the cost of a bag of popcorn. Sometimes it's the cost, sometimes it's the number of that item, but it's really good to keep track of what it is specifically that you're finding. So they said it was 4 fountain drinks. So the number of fountain drinks multiplied by the cost of the fountain drinks. 4 times D plus 3 bags of popcorn plus 3 times P equals $22.50 for the first line. 5 times D plus 2 times P equals $23.75 for the second line. In my opinion, these are probably the easiest ones to write because they literally say it in words and then you just write it in symbols and you're ready to go. So I think these ones are probably the easiest. This is definitely elimination. And if you were to do this one with elimination, what variable would you guys probably want to eliminate? Do you guys have an idea of what would be easier for you? P? Sure. So the P's, we would have to turn them into what? 6. And how would we do that? We could do -2 for the top line. That would make this a -6. And then what would we do for the bottom line? +3. Okay. I'm going to leave that problem there. I'll let you guys finish that one there. The next problem I'm going to do is actually the third problem. This one's right next to it. It says at the gym. So if you look to the right, the next problem says at the gym, Kara burns 12 calories per minute on the elliptical and 10 calories per minute on the treadmill. If she worked out for 1 hour and burned 676 calories, how many minutes did she spend on the elliptical? These types of questions, and there are quite a few of them on this worksheet, these are the ones that tend to mess with people the most when they write them. Usually you can kind of figure out how one equation should be written, but you're not quite sure what the second equation should be. It feels like there are 4 numbers in the problem. And so you're like, if there's 4 numbers in the problem, how do I write 2 equations from that? So these are the ones for me where writing down what the variable means is the most important thing. So I have E for elliptical and T for treadmill, but I have to think about what the E and the T actually stand for because it's not like an actual treadmill or an actual elliptical. Are we talking about the cost of the elliptical? Are we talking about the number of time spent on it? Are we talking about the number of calories burned on it? What are we talking about with the elliptical? Can you tell from the problem? What does it say? And the hint is in the question they ask. The number of minutes. So this is the number of minutes on the elliptical. And this is the number of minutes on the treadmill. Okay, and then if you look at the problem and these types of questions, there's usually 2 sets of information that they'll give you. So in this problem, the 2 sets are, they talk about 1, calories burned, and then the second thing they talk about is time. So that's what our 2 equations are going to be based around. It's going to be based around the time that you spend exercising and then the amount of calories that you burn while you do so. So for my first equation, I'm going to talk about calories. So how many calories do they burn per minute for the elliptical? 12. So I'm going to say 12 calories for each minute on the elliptical. What about the treadmill? 10 calories per minute on the treadmill, and then how many calories total should that be? 676. Okay, so that's the first set of information. And then the second set of information is time. So now I want to talk about time on the elliptical, time on the treadmill, and then time total. So the time on the elliptical and the time on the treadmill, those are literally just us writing down the variables. So time on the elliptical, time on the treadmill, equals the total time, which is how much? 60 minutes, because they said 1 hour. So even though they only gave us 4 pieces of information, those 4 pieces of information, 12, 10, 676, and 1 hour, those 4 pieces of information were actually the perfect amount to write 2 equations. Does that make sense? Okay, so now we just have another elimination problem, and we can either eliminate the e's or the t's just by multiplying by 12 or multiplying by 10. But the opposite sign, so negative 12 or negative 10 for the second equation. But this is very common. This is very common. For instance, if you were to look at the next problem, Angela has a collection of nickels and quarters worth $8.80. She has a total of 68 nickels and quarters. How many nickels and quarters does she have? If you were to look at that problem, there's 2 sets of information. It's the value. The value is one set of information. $8.80 is talking about the value. We know that nickels are worth 5 cents. Quarters are worth 25 cents. So one of your equations would be about the value of a nickel, the value of a quarter, the value of the coins overall. And then the second thing that the problem is talking about is the number of nickels, the number of quarters, and then the number of coins overall. Do you guys see how there's 2 sets of information there? So that's what your 2 equations would be based off of. So in this worksheet, those are the ways the equations are written, and they're kind of hard. If you're not paying attention, it would be hard to figure out how to write the equations. But if you start to pay attention to that, you'll be like, oh, a lot of these are written that way. Does that make sense? Okay, so I'll let you guys work on that for the remainder of the period, and then if I was you, I would focus on this worksheet instead of finishing the other one, because I think the other one will be easier to finish at home. I think this one is the one that would be more difficult as far as writing the equations, okay? So go ahead and work on this one, and then let me know if you need help setting up any of the equations.